In this video, we are going to look at how we can convert the time surface. As you see here, I have an example cell, and you see my surface is located at a depth of negative 2000 millisecond up to about 750, right? Somewhere here, and up to about 1600 millisecond on top of the SAT diaper. Everything here you see, it's in time domain. We need to convert it to the depth domain. Basically what we do is we create several horizons in different depths, one at the depth of 0, right? One close to the bottom and several in the middle. And we use a lot of borehole data. We use a lot of check shots. In this example, we have only one borehole data, and therefore doing the advanced velocity model somehow impossible, and it has a lot of complications. So we are going to ignore doing the advanced velocity model because we don't have enough data to do it. What we are going to do, we're going to go step by step, and you will find out how we can transfer data from time domain to the depth domain. And I think it's more informative and you learn more basics. Before going through that, I need to show you a picture from the North Sea. So what you see here is the oil rigs, right? And as you see, the drilling platform, it's up there above sea level. And this distance from the sea surface to the drilling platform, it's called Kelly bushing. All right, so why that's important? Because when we start measuring, okay, any type of logs, any core, any depths along the borehole, the origin or 0 indeed is here. It's not at the sea surface. All right, for the log data, the origin is here, but for the seismic, the origin is here, the sea surface. Why? Because I already showed you when they are going to do the seismic mapping, right? The source and receivers are at the sea surface, right? So the origin of the seismic data, it's sea surface, okay? So for calculating the velocity model, okay, you should take this Kelly bushing into account, otherwise it's gonna bias your calculations. Let's have a very simple image about the terms that we use. Here the picture, it shows the land situation, but it's the same as offshore. You can imagine the platform is this much high from the sea level. As you see here, from the sea level to the drilling platform, it's called KB, all right? And from drilling platform down to the well along the trace, it's called measured depths. And TVD stands for true vertical depths, all right, which again its reference, its KB, starts from the Kelly bushing and it goes down. For us that we are going to create a velocity model, we're going to use two-way time, and you need to push the origin of the distance also to the sea level. All right, so what I'm trying to say is, rather than using the MD, all right, you need to use the depths, right, or the true vertical depths. For our case, it's a little bit easier because our borehole is vertical. If you just say the measured depths minus Kelly bushing, it's going to give you the true vertical depths, or let's say the depths or Z, and we're going to use that one to calculate the velocity. All right, let's see how we can do in Petrel. We have two-way time and we have the depths as well, because the software will calculate it automatically. You don't need to do anything about calculating depths or correcting for the calibration, but you need to know which column of data you're going to use for velocity modeling. All right, so for doing that, let me close this first. For doing that, you need to make a new window. You go to home, you create a new window as a function window. All right, and in the function window, you need to plot the two-way time in the x-axis and depths in the y-axis. All right, so where those data are, you need to go under wells, under global well logs. You have your check shots, right? Under check shots, open up the attributes, and here you have the data. So I'm gonna plot the two-way time on x. So I'm gonna click first on the two-way time, and as you see in the box is written x. And then I want to plot, okay, z, because this is corrected for the calibration, but this measured depths includes the calibration, right? So I'm gonna click on z, which is depths, and as you see in the box it says y, right? This is plotted on x-axis and this is plotted on y-axis. So you have the data here. This is your time depth relation, and what we're gonna do, we're gonna fit a line and get the function. For doing that, you go to nonlinear functions, open up that one. We're gonna do nonlinear function degree of 2, and then you don't really need change anything, just click OK. All right, the curve is made and actually end up to be a file here for us, right? You see now we have this one in our document, and we're gonna find out the function. You can double click on that, go to info. Here you have the function. All right, this is the function, and here y is depths, x is time, right? If I use this function, I can convert the time, which is x here, into the depths, which is y. So here, for simplicity, the software, it gives you, okay, the calculator format. You need just select and copy this function. All right, you can close this. You go to 3D window, and here you need to activate a calculator. That calculator is under the easy way is you go to the seismic interpretation, click the calculator. You see right now this file is selected. See the select attribute here, right? I'm not able to see my layers, so I want to close this and select one of these horizons, the cell, right? And then click the calculator, and now you see, okay, the function of the calculator is changed, right? So you need to select this and copy your function here. The y, it's gonna be your new file, or in another word, cell in depth domain. Okay, I can call it cell depth map, right? And make sure this is underlined, because if you put line, that's gonna be a problem, because line here, okay, it means minus. So we named it a new file, and wherever you see x, one is here and the second one here, just select x and then click cell. It means we are replacing x with cell. All right, and then when you are done with this, just click enter. All right, it creates you a new file. You can close this, we don't need anymore. And if I click on that, okay, you're gonna see in two-way time, right? But I need to see it in this environment, in the true vertical depths, which is the depth domain, right? So this is in the time domain, but I know this is indeed is in depths. For correcting this, double click on the file, and then you go to info tab, and under template, which is the elevation time, just change that one to elevation depths. Click apply and OK. Now, as you see, just grayed out because it doesn't belong to the time domain, right? Now, if you switch to the depth domain, you're gonna see it here. All right, now this is my depth map, and as you see here, okay, cell depth map, this is the scale. Wherever you see the purple color is a depth of 2150 meters, and the top of the dot there appears at a depth of 1650 meters. So let's check to see how much error we have, right? So first of all, let's look at to the function. As you see in this curve, you see these two dots are off, right? You see some of them off, and for sure for these steps we're gonna have some kind of discrepancy, right? And as you see, our depth map, all right, it's sitting somewhere between 1600 to about 2100, and here between 1600 and 2100, something like here, right? And as you see, we're a little bit off, so you will end up having some error, right? That's normal, right? But if we have more borehole data, if we have precise work, if we have many check shot points, then we can have a better function, and we can actually convert the time domain to depth domain with a minimum error. But still, having said that, our error is not huge, okay? It's just small, because relatively speaking, I see this line has a really good fit to the points that I have here, right? Let's see how much error we have and how we can calculate it. Go to 3D window, zoom into the well trace, and how I zoom in, I just hold shift and control and left click on my mouse, and then I just move my mouse towards myself, right? And then you can zoom in. Now I'm moving up and down. Now I have shift, left click, and moving mouse towards myself or away from myself. In that case, that's gonna move in that way. Again, I'm holding, at this situation, I'm holding control and then moving mouse towards myself, right? I'm zooming in, all right? So again, control off, move up, okay? A little bit control and move mouse away from you, okay? I'm just trying to show you how you can work easily with your mouse and keyboard. All right, so this horizon, it's in depth horizon, and we calculated this, but when I'm comparing this with the borehole data that is recorded on site, I see the cell formation, it has to be here, but I end up here, right? This much is my error. How much is that? You can take the ruler and then you can click in the middle of the dot and then click, or on the surface, right? Click there, and at the bottom here you're gonna have different numbers, right? So I'm interested to depths because I want to know what's the depth difference between the measured cell formation and calculated cell formation, right? And in this difference, it's about 62.2 meters, right? Let's say 62 meters. What is the depth of the cell? Okay, the cell is sitting at a depth of, I just take the select, click on the middle of the cell and look at to the bottom right corner. It says depth, right? It's 1800 meters almost, right? So can I say in 1800 meters I have 60 meter of error? Can I calculate the percentage using these numbers? Let's do that. Bring your Excel, and then you say the total depth to cell, it was about 1800 meters. If you say this is 100% of distance, what would be the percentage of 62 meters? So here I can calculate the amount of percentage, 62 multiply by this divided by this. All right, I'm getting 3.4, and this is your error, right? my calculation from time to depth domain, it has 3.4% of error. All right, we can reduce this error if we have more well data and we have more check shots. So if you open your check shots, probably you will see like 20 points, right? But having said that, our calculation based on only one blowhole data, it's very, very precise. So I have my depth map for cell, and the point is, for this practice, you are going to do the same work for Balder and Ekofisk. All right, this is my depth map, and if I go to the 2D, let's zoom out and let's uncheck the wells, and uncheck the study area cell. You see, this is my map. This is not the one that you normally use it if you want to deliver to somebody, or you want to include in your publications or your report. If you want to take a snapshot of that, would be fine. Would be okay, because it has a north direction, it has a scale, it has a index, right? Everything is included, and it has a coordinate, right? This is a shortcut to the layout. But we have another way of doing that, but I think we will just use this and take the snapshot of that. I don't want to load you with some details that you may not really use it. All right, so that's pretty much it. You can change the color of the background by clicking on this. Either it's going to be white or black. If you are going to use the white, you're going to have a little bit difficulty of reading these numbers here, right? So you can change the color of those. It's not big issue. I don't really want you guys go into details. You can actually keep the black color in the background if you want to provide a map for your projects.